I hope you can see the blank screen, right? All of you?
Yes, sir.
Yes.
Okay.
Yeah.
So the topic for today, to break the monotony of pharmacology, the topic for today is we are going to look at naming of heterocycles. I have already explained to you why we are studying heterocycles since they are part of so many drugs. So the first stage of study of heterocycle begins with nomenclature of heterocycles. Okay, and basically there are three systems of naming the heterocycles. First system is nothing but what is called as trivial names, or some may call it as common names. Okay, the second system is derived or it's put forth by two scientists. So it is named after them. So it is called as Hansch-Widman system. Okay, and the third system is relatively not so relevant when it comes to organic chemistry, but still it is there. It is called as replacement nomenclature. So these are three systems. Whenever you talk about nomenclature of heterocycles, these are the three systems which are really commonly used. Out of these three, what we are going to study today are mainly these two. So main focus of today's lecture is going to be these two systems, which is trivial names and Hansch-Widman system. Okay. So I hope you know what we are going to do today. And as I told you on the group, it may take more than 1 hour. And you might feel kind of saturated and confused with a lot of different sounding names. So I will try my best to sort of make it simple. Okay. So let's start with the trivial names. So the first system that we are going to look at is trivial names. Okay. Now, as you know, there are almost 35 to 40 trivial names you have to remember, right? And how many of you feel this is a very daunting task? How many of you feel this is very confusing, remembering trivial names? Hello?
So we are raising hand.
I cannot see, so you have to speak up. Since my screen is shared, I cannot see the raised hands.
So me.
Me.
Okay, so I know it sounds confusing right now, but the only thing you can do is you have to draw them and practice the names. So this is the first thing that you have to take. You have to put it in your minds that unless you draw it again and again, those names will not sound familiar. You will always get confused when it comes to trivial names. So I will try to sort it out in a way that it is easy for you to remember them. Okay. So if you want to sort of divide these 35-40 names, I can think of a variety of classes. Okay. So let's start with the first class of trivial names. Okay. So the first class actually involves those containing one or more nitrogens. Those containing one or more nitrogens. Okay. Are you with me as of now?
Yes, sir.
Now,
Yes.
just to clarify what all we are going to see in this particular thing, because this occupies almost 50% of all the heterocycles. Okay. So this broad class can be subdivided into three classes. Okay. So the subdivisions include those heterocycles which have single ring. Okay. Those heterocycles which are bicyclic. And as of now, only one drug or only one heterocycle we are going to see, which is a tricyclic ring. Okay. So the rings with more than one or more nitrogens can be further subdivided as those containing single ring, those containing bicyclic ring, those containing tricyclic ring. Now when it comes to cyclic, it can be further divided into two subclasses. Okay. One of the class is that carbocycle fused with heterocycle. I hope you are I hope you are understanding what is the meaning of carbocycle. Can someone tell me what do you think is the meaning of carbocycle?
Atom attached.
Nitrogen or carbon.
No heteroatom. Carbon means any such ring with no heteroatom, only carbon and hydrogen. For example, benzene. It's hydrocarbon ring, right? So if a benzene ring is attached to a heterocycle, that will come in particular category. Any doubt as of now? Any doubt as of now?
No, sir.
Okay. And the second type is, as you may probably guess, it is heterocycle combined with heterocycle. So bicyclic rings are further divided as two, that is carbocycle plus heterocycle or heterocycle plus heterocycle. So I hope you are getting the bigger picture. These 18 names, these 18 common names are going to be divided into these three categories, that is single rings, bicyclic rings and tricyclic rings. Among bicyclic rings, they can be divided into two further classes, that is carbocycle plus heterocycle, heterocycle plus heterocycle. I hope you are getting the picture, a sort of overview that we are going to see. Right?
Yes.
So
Yes,
let's
sir.
start with the first class, that is single rings. Now you can tell me the names. I will draw the structure. You can also draw with me, but you can tell me the names also. The simplest one, anyone?
Pyrrole.
Pyrrole. Okay. Now if I add more nitrogen here, can someone tell me the name?
Imidazole.
This is not imidazole.
Pyrazole.
Pyrazole.
Who said that?
Imidazole.
This is actually pyrazole. And this is actually imidazole.
Imidazole.
Okay. So then let's move on to the next ring, which is a 6-membered ring. What is this ring?
Pyridine.
Pyridine. Now, when it comes to more than one nitrogen here, there are several variations which you can think of, right? So nitrogen can occupy sort of 1 and 2 positions, correct? So what is this ring called with nitrogen as 1 and 2?
Isoquinolone.
Huh?
Isoquinolone.
No. Quinoline is a bicyclic ring, whereas we are at single rings.
Pyrazine.
This particular ring is called as pyridazine. Okay, pyridazine. Nitrogen as 1, 2, it's called as pyridazine. Okay, now next variation comes with nitrogen as 1, 3. This should be familiar. What is this ring?
Pyrimidine.
Pyrimidine.
This is pyrimidine. And nitrogen has 1, 4. Anyone?
Pyrazine. Pyrazine.
Yes, it is pyrazine. Perfect. This is pyrazine. So at least some of you may have heard about this drug called pyrazinamide, right? So the name is derived from pyrazine because it contains pyrazine ring. So if you put an amide here, that is the structure of pyramide. So now you are getting it. We are not merely studying these rings for the sake of studying it. We are studying it because they are part of so many drugs. Okay. So these are the single rings containing one or more nitrogen. Now, if I remember, you were confused with pyrazole. So you can put a star mark here, and you are confused with pyridazine. So you can put a star mark and be very careful when you are talking about these two rings. Is that okay? So this is a common trick to identify where you are finding it difficult to remember the names. Is that okay? So from what I could understand, these are the two names where you are finding it difficult. Is that fine? Hello?
Yes, sir.
Okay.
Yes,
Now
sir.
let us move on to the bicyclic rings. Okay, with nitrogen. Bicyclic rings. As we saw, the first subclass among bicyclic ring is carbocycle plus heterocycle, right? So this is the first class, that is carbocycle plus heterocycle. All right. Now the most common rings that come here. Now while you are drawing these rings, make sure that you are drawing a double bond here at the junction of benzene ring. Okay, benzene and 5-membered ring. So always remember the double bond has to be shared between the two rings. Is that okay? So what is this ring?
Indole.
This is indole. So tryptophan contains indole ring. Okay, many other things contain indole ring. You must have heard about auxin and gibberellins, plant growth hormones, which are required for plant growth, right? So
Yes.
auxin is nothing
Yes.
but indole acetic acid. So auxin contains indole. So many things contain indole. Alkaloids like reserpine contain indole. So there is a special category of alkaloids called as indole alkaloids. So that is why indole ring is such an important ring. Okay. So the next ring is a benzene ring fused with an imidazole. So the name is very simple, benzimidazole. Okay. So the common name is benzimidazole. Now you will be learning about anthelmintic drugs which contain this benzimidazole ring. All right. So it is part of many anthelmintic drugs. Now let us move on to benzene ring attached to a 6-membered ring. So here comes your famous names that you have already told me. Can someone tell me what is the name of this ring?
Quinoline.
Quinolone.
This is quinoline. Not quinolone. If you say quinolone, that suggests that there is double bond O present somewhere. So on indicates that it is a doubly bonded. There is a presence of C double bond O somewhere in the ring. So quinolone is different. This is quinoline. Okay. Many anti-malarial drugs are quinoline containing, and very recently, bedaquiline, which is an anti-TB drug, contains this quinoline ring. Okay. Now, if I shift the nitrogen, what is that ring called? If I shift the nitrogen here, anyone?
Isoquinoline.
Isoquinoline. So it is a isomer of quinoline. So morphine alkaloids, papaver somniferum, the alkaloid belonging to family papaver somniferum, belong to this isoquinoline alkaloid category. Okay. Now, all of you know that numbering starts from heterocycle, right? So if you want to number quinoline, it should start from nitrogen, like this. Do you agree with this? So this is how the numbering starts with bicyclic ring. If you want to number indole, it is something like this: 1, 2, 3, 4, 5, 6, 7. Even benzimidazole, 1, 2, 3, 4, 5, 6, 7. What is the peculiarity that you are observing in this numbering? Can someone tell me?
The bridge carbons are not given.
Bridge carbons are not given any number unless there is a heteroatom present at the bridge. Okay, so always remember this. Unless there is a special addition, for example, if it is purine, there is some different numbering system, or there is some heteroatom present at the bridge junction, then and only then you number the bridge. Otherwise, you skip the bridge. Now, when it comes to isoquinoline, the numbering should, as per the rules, should start from nitrogen, but no, it starts from this carbon only. So nitrogen gets second number. Okay, rest of the numbering remains the same. So remember, in isoquinoline, nitrogen has a second position. Okay. Now, the trick comes, or the confusing thing comes, when benzene ring is attached to something which has more than one nitrogen. Okay. So let's look at those possibilities. So the first possibility is here. So benzene ring is attached to a 6-membered ring with nitrogen present at 1, 2. Do you remember name of this ring? Nitrogen has 1, 2. Anyone?
Thalazine.
Huh?
Thalazine.
Thalazine. This is called as sinoline. This is a sinoline ring. Okay. So make a star mark here. I think you are confusing thalazine with this. So this is a sinoline ring. All right. Now let's shift the nitrogen to 1, 3. So what is this ring called?
Quinazoline.
Quinazoline. Correct. This is called as quinazoline. So have you heard of Adursa, everyone?
Yes, sir.
Adursa?
Yes, sir.
Adursa is obtained from plant called as Adathoda vesica, or in common terms it is called as Vasaka. So Vasaka belongs to category of quinazoline alkaloids, which is used in cough or respiratory conditions. So Vasaka belongs to this particular category of quinazoline alkaloids. Okay, Adathoda vesica is the biological name. The common name is Vasaka. Okay, you use leaves of Adathoda, dried leaves of Adathoda vesica Nis. So that is Vasaka, belongs to of quinazoline alkaloids. Okay. Now, if I shift this to 1, 4, what do you think is the name of this particular ring? Nitrogen are 1, 4. This is 1, 3. Quinoxaline. Correct. Quinoxaline. Only one person answered, so I guess everyone else is confused. So I'm putting an asterisk here. So nitrogen as 1, 4 is called as quinoxaline. And the last possibility that someone already told the name, that is thalazine. The last possible structure that you can draw with this is nitrogens at 2 and 3. Correct? Nitrogens at 2 and 3. This is nothing but thalazine. So I am putting a star mark here also. So since you are confused between thalazine and sinoline, I am putting a star mark. So what I want you to do is go through the heterocyclic names that I've done so far. Okay, shall I go to last slide? Shall I go to the last slide so that you can see? So we started off with compounds with one or more nitrogens. One or more nitrogen compounds were divided into 3 subcategories. The first class was those which contain single ring, those contain bicyclic ring, and those which contain tricyclic ring. The ones which contain the bicyclic ring are further divided into 2 subclasses, that is homocycle plus heterocycle and heterocycle plus heterocycle. Okay, so we saw single rings, which is pyrrole with nitrogen at first position, pyrazole with nitrogen as 1, 2, imidazole with nitrogen as 1, 3. So these are the most common 5-membered rings. In 6-membered rings, pyridine is 6-membered nitrogen, only 1 nitrogen in pyridine. 1,2 nitrogen is pyridazine, 1,3 nitrogen is pyrimidine, and 1,4 nitrogen is pyrazine. So this was about single rings. Okay. Then we moved on to bicyclic rings. In bicyclic rings, there are two subcategories. First category is combination of a carbocycle and a heterocycle. So in that we saw indole, we saw benzimidazole, we saw quinoline, we saw isoquinoline. Remember, in isoquinoline, nitrogen occupies the second position. Then we saw combination of a benzene ring and a ring containing 2 nitrogens. So when nitrogen is at 1, 2, it is quinoline. When nitrogen is at 1, 3, it is quinazoline. When nitrogen is at 1, 4, it is quinoxaline. And when nitrogen is at 2, 3, it is thalazine. I hope now at least some confusion is sorted when it comes to these comments, right?
Yes, sir.
Yes,
Shall we
sir.
go ahead? Or is it becoming too much just now?
No, it's
No, sir.
bit
Okay, not
clear.
as of now. All right. So let's go ahead with the subclass of bicyclic rings, which is heterocycle plus heterocycle. Now there are two important rings here. Now remember, I have included only those rings which are part of some or the other structure. Okay. So the first important ring here is this. I hope someone can identify it because it is a very, very well-known ring to you. Anyone can identify this? It is a combination of a pyrimidine and an imidazole. So can you identify this? Anyone? So I am going to put a star mark here. When I tell you name, you are going to say, "Arey, we should have identified this." You have studied this in biochemistry also. This is purine.
Okay.
This is a purine ring, okay, which is a combination of pyridine and imidazole. All right. And the next ring, I hope some of you at least can remember this because we have seen it 2 lectures back, 2 Sundays back, when we were studying about pharmacology of sulfonamides. So it is a combination of pyrimidine and pyrazine. Yes?
Pteridine.
Pyridine. Perfect. Pyridine ring is a part of acid, right? So it is a pyrazine on one end and pyrimidine on other end. So this takes care of bicyclic rings. Okay. And as I told you, I have got only one tricyclic ring with one nitrogen. Okay. So can someone tell me the name of this? So it is a benzene ring. In between, it is a 5-membered nitrogen and another benzene ring. So pyrrole ring flanked by 2 benzene rings on both the sides.
Carbazole.
Carbazole.
Perfect. Perfect. So carbazole. Absolutely right. So this takes care of first class of common names or trivial names, that is the rings with one or more nitrogens. Okay. And if you look at it, we have already covered around 18 rings. Just count the number of rings that we have covered. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So almost 50% of the rings are done here. Common names are done here. Is that okay?
Yes, sir.
Yes, sir.
Okay. Let's go ahead. I hope now you are finding this little bit simple with this type of system, right?
Yes, sir.
let's go ahead with heterocycles containing oxygen. The second main category, those heterocycles which contain oxygen. And the simplest one, I think everyone should be able to recognize. The old name was ethylene oxide. You must have studied this in microbiology also. It is used as a gas sterilization agent or simply epoxide. So ethylene oxide or epoxide. Now, I hope everyone can tell me what this is.
Furan.
Furan. Now, what is the property of furan that makes it so special? Although it may look like heterocyclic ring with lone pair of oxygen attached to it, oxygen being very electronegative, it's sort of adamant to donate the lone pair, right? So furan mostly acts like a conjugated diene rather than a heterocycle, right? And that is why it gives a very famous reactions which is called as Diels-Alder. Is it correct as of now?
Yes, sir.
It's covered, right? So furan, owing to its nature, since it is acting more like a conjugated diene rather than aromatic heterocycle, it is known to give this particular reaction, which is called as Diels-Alder reaction. Okay. Now, can someone remember the name of this 6-membered ring with oxygen? Anyone? Anyone remembers? We have seen this in sugar.
Pyran.
This is a pyran ring. Okay. So if you remember, glucose occurs as pyranose form and fructose occurs as furanose form. So this is a pyran ring, membered ring with oxygen. Now there are some bicyclic rings when it comes to ring containing oxygens. So the important ring is fusion of benzene and furan, which is called as benzofuran. Okay, it is a fusion of benzene and furan. It is called as benzofuran. All right. Now, can someone identify this ring? Let me draw.
Chromine.
Okay, so you are right. Essentially, you are right. But remember, guys, if you see here, this particular carbon is saturated. Do you agree with this? Correct?
Yes, sir.
Yes, sir.
Numbering this particular ring, it will start from oxygen, right? So let's number it first and then see what I want to say. So this is the kind of numbering that you have when it comes to chromine, right? And if you see here, this second carbon has actually, it is a saturated carbon, right? As opposite to other carbons. Do you agree with this? So since
Yes.
at second position, it is carrying an additional hydrogen, it can be named as 2H chromine. Okay, so this particular 2H actually signifies the location of additional hydrogen. Okay, so this is called as a 2H chromine, but essentially, right, it is called as a chromine ring. Now, what will happen if I add one more carbonyl to chromine? Anyone remembers the name of that ring? So if I draw a chromine ring, okay, and if I additionally draw a double bond here, double bond O, what do you think is the name of this ring? Anyone? Anyone remembers? This is called as coumarin ring. Okay, so you are going to study anticoagulants, I think, this semester, pharmacology. Hello.
Maybe so. We have blood products as a chapter.
And clotting factors, blood products, right? So anticoagulants, those which stop coagulation from happening. So those, many of them in this coumarin ring. All right. So coumarin is a very important ring, right? So this takes care of rings containing oxygen. So just go through the names once, then we can move on to the other rings. Let me know once you are done. Start from the beginning. Okay. So sometimes coumarin ring is also called as benzopyrone. Okay. So sometimes this is also called as benzopyrone, one indicating the presence of C double bond O. Okay. So this is a coumarin ring. Are you done, guys?
Yes, sir.
Everyone?
Yes,
Are
sir.
you done? Okay, okay. Let's go ahead with sulfur containing only two structures here. Okay, those which contain sulfur, thiophene, 5-membered ring containing sulfur, thiophene. Do you know any speciality of this thiophene?
Number of resonance structures are more.
Okay, so thiophene has a sulfur atom. Okay, so sulfur is a big atom. Agree? Sulfur is a big atom. So thiophene usually occurs when we are trying to hunt for benzene. So if, as you all know now, we get benzene from petroleum products, right? By cracking of petrol and everything, right? This is one of the method of getting the hydrocarbons. So along with benzene, because they are size-wise so similar, you also get traces of thiophene. So one way to get the thiophene is by cracking of petrols. Because sulfur is a big atom, thiophene also has a big size, almost similar to benzene. And if you look at the resonance energies of uh, benzene and thiophene, I hope you understand what I mean by resonance energies. So resonance energies are basically indicating the stability, right? So if you look at the resonance energies of thiophene and benzene, they are almost similar. That also is indication that thiophene is very much alike with benzene. Is that okay? And the other drug is, of course, other more compound is, of course, thiophene attached to benzene. So this is benzothiophene. Is that fine? Is that okay?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Let's go to the next broad category of heterocycles, which have combination of heteroatoms. which have combination of heteroatoms. Okay, so let's start with nitrogen and oxygen. Okay, can someone tell me what is the name of this particular heterocycle? Anyone?
1,3-oxazole.
Sorry?
1,3-oxazole.
That is the IUPAC name. Common name? This is called as oxazole. So when nitrogen and oxygen are oriented as 1,3, okay, so it is called as oxazole. And when nitrogen and oxygen are oriented as 1,2, it is called as isoxazole. We are talking about common name, right? So right now we don't want to worry about 1,3 or 1,2. So the 1,3 isomer is actually called as oxazole. 1,2 isomer is actually called as isoxazole. Okay. Okay. What about this? Sulfur and nitrogen. This is
Isole.
azole. Okay. Now let me add one more nitrogen. What about this? This is called as thiadiazole, right? And one more last commonly used heterocycles in drugs, commonly found heterocycle in drug, 2 nitrogen and oxygens, oriented as 1, 3 and 4 is called as oxadiazole. Okay, so these are the commonly found heterocycles with combination of heteroatoms and their common name. So you need to really worry about these two only in this. Others are quite straightforward. You have to be very careful when you are talking about oxazole and isoxazole. So let me repeat. It is called as oxazole when nitrogen and oxygen are like 1,3 oriented, and when it is 1,2 orientation, it is called as isoxazole. Is that okay?
Yes, sir.
Yes, sir.
Yes, sir.
Last category of trivial names belong to saturated heterocycles. Okay, some heterocycles which are saturated, they don't have any double bond. That is the last category of trivial names. Okay, so it starts off with saturated pyrrole. What it is called? Anyone knows name of this?
Pyrrolidine.
Pyrrolidine. What about saturated ring with oxygen? What this is called?
Tetrahydrofuran.
THF, tetrahydrofuran. It is used as a solvent in many of the reactions. Have you studied Grignard reaction?
Yes, sir.
Yes, sir.
Grignard reaction, THF is used along with the Grignard reagent as a catalyst, right? So THF is a very good solvent. Okay. Pyrrolidine we have already seen as part of proline. Okay. And as you will realize ahead, pyrrolidine is also present in structure of captopril. All right. So captopril. Captopril is a ACE inhibitor. First ACE inhibitor. It started, the discovery of captopril started from the presence of proline itself. So captopril also will have pyrrolidine. Now, the next confusing ones. I hope you are not confused in this, but rather confusing to everyone else. What is this?
Piperidine.
Yes. Can you repeat, Rutvi?
Piperidine.
Piperidine. Perfect. Piperidine again used as a very good base or solvent. Okay. If I put another nitrogen, what is this?